Hello friends, today I'm going to discuss about the various databases on which I have knowledge. In all web applications or distributed applications, we use a lot of databases like Oracle, SQL Server, Sybase, MySQL. So I have knowledge in most of them, and I have also knowledge in relational database, graph database, and XML database. So if we are having like structured or relational database, then we can use like relational database. But if the data is like semi-structured or not well connected, we can also use graph database or XML database. So this is XML database is also nowadays a lot of popular database system. So this is Microsoft SQL Server Management Studio version 19.2, and if we like connect it here and see about the various like database objects which we can work on, and here we are having a database I created with the name Financial Products DB, and we have got like different tables which I created. So if we see like these three tables, find financial product sales, financial products, and XML table, and then if we see we are having like we can run a query which will be like selecting top 1,000 rows in the data. So here like sale ID is like a primary key. So when we create a table, then we can define which column will be like primary key. So all the data will be unique in that. Similarly, we have data in fin products table with the like three columns: product name, customer address, product ID, and we have got XML table also, which will be discussed soon. So for XML table, we can have like a whole XML data being inserted in the table, whether it's like a native XML storage or we use AXSD, like annotated XML schema database object, where database columns like XML fields can be decomposed into one or more columns from one or more tables. So here and in database we can also have like views, joins, left join, right join, full join, and make like different subqueries or complex queries where we can have a data within the data. So we can use like in between or greater than, less than operator. These operators which we can use to find a particular data, and then using a second query to like find the sub data. So here we can use procedures. So in programmability, we can have different stored procedures. Like this one, I created find products proc and dbo.insert products proc. So if we want to modify, then we can modify here. It basically in this stored procedure is having like select statement where product ID is greater than 115 from the table fin products, that is this table. And if we like execute this product and click on OK, then we can have like all the data where that fin product value is greater than 115. And similarly, we are having like insert products proc. This stored procedure we can have like used for inserting data into the fin products column. We are having prod name, address as the like input parameters where we can enter the values and specify. And so these like database objects, whether it's queries or stored procedures, we can use it directly with Angular or React or some other applications, and we can run the stored procedures or the queries from there and in any of our web application or any other distributed application. So coming back to other tables and this graph database, we are having uh, the tables. We are also having a name we can see as graph tables. So here in graph tables we are having like different tables which are used in graph databases. So in graph database we are having nodes and edges which can be stored as a table. If there is a sparse data, like not well connected data, but some rows are like connected with each other from some different tables, we can we can create a table as a node and describe a relationship between those nodes through edge. So if we see like the tables in these uh, so this one is like a node table, and it has column like ID, nickname, and address. So we can see also here in the data like its type is node and schema is DBO, and the table name is like premium customer. And this one is also a table of type node, and this column node underscore ID, it is automatically created when we insert the data in the table, that these values and this field will be like auto generated within our node table. And if we look at the edge table, which is like a relationship between two graphs, we are having three columns like edge ID, from ID, and to ID. From ID and to ID are like related to node, and edge ID is like auto generated, indicating that it's like a edge table. So if we look at any particular data, let's say we look at this row. So this is a relation between table customer and customer itself. So this indicates that this data belongs to the customer table itself with the ID 6 and ID 7. And if we look at, say, this row number 7, this is a relation between two node tables, customer and premium customer, and the edge table name is product by. So customer ID 3 and premium customer ID 2 we are having here. So if we look at premium customer ID 2, so this is the like edge is relation between the row with the nickname Jim, and this is 3. So customer is having 3. So Jim, and if we look at premium customer, it's Smith. So the Smith is nickname is with the premium customer ID 3. So this particular row is having establishing a relationship between those two like customer names with Jim and Smith from table customer and premium customer. So similarly, we can, if there is a complex data, we can also have shortest path between nodes. Like if there are 15-20 nodes, then we can find which is the shortest path, which is, it is only used within inside match clause, where we can have a plus symbol to indicate one or more repetitions, and 1 to n to indicating 1 to n times query to find the match data. So we are having a couple of queries also if we run here. So this table is having a match where customer between customer and premium customer, where customer name is NKBC and customer name is Nick. And this table is, if we execute the query, it is also showing name and age, and in the shortest path between customer table and premium customer table, as well as customer name is either NKBC or customer name is Nick. So similarly, we can have edge constraints, where we can define that if there is an edge table where the edge table like this one. So in the edge table, which we can establish a constraint whether on which tables this relationship should exist, and in, so if we want to insert any data in the edge table where it is outside those specific tables, then it will give an error. And we can have on delete no action or on delete cascade, indicating whether we want to delete any particular row, then subsequent nodes data will be deleted as a cascade action or no action when there will be like error in if we try to delete any data. And in databases we can also have ledger, which indicates for like having historical data to have a backup of data. And in recovery model we can have simple, full or bulk log, whether the recovery model is simple where we are having like no backup, or full backup where all data is having have a backup in case of failover, or there is like a server crash or some problem in the database server. And in bulk logged we can have a database backup to a particular point. So if anything happens after that, those queries will have to rerun again to insert the data and update the information. So we can have like different recovery models within databases, which indicates to have like a backup according to our requirements. So this all these databases, whether XML database, graph database or relationship database, can be used in different backend operations and software applications, and it can be integrated with Angular or like other frameworks like Spring MVC, other frameworks to display the data or like read, update, delete any information. So thanks for listening to my video. If there is any like opportunities in as a backend developer, then please let me know. And also for any queries, I can be contacted at my mail ID vgosainjob@gmail.com. Thanks for watching.